So for those of you who take physics or mechanics, you may recognize these two equations as the first two equations of motion. In today's video, I wanted to take a look at how we derive these equations. So in order to derive the first equation of motion, we need to know what acceleration is. Acceleration is defined as the rate of change of velocity with respect to time. So we can write the following equation. A is equal to dv divided by dt. Now remember, this is for uniform acceleration. So let's rearrange. dv is going to equal a multiplied by dt. Now since we're dealing with uniform acceleration, we can take the integral on both sides, but taking a out. So the integral of dv is equal to a multiplied by the integral of dt. Now let's assume an object moving from some initial velocity u to some final velocity v in some time t. The change of the velocity is simply going to be v minus u, and that's going to equal a multiplied by the change in the time is simply going to be t. And now we can rearrange. V is equal to u plus at. Now let's try and derive the second equation of motion. I'm going to use this graph, this velocity time graph, and we know that the area under a velocity time graph gives us the distance traveled. Now I've divided this shape into two. So I have a shape 1, that's a rectangle, and shape 2, that's a triangle. So the distance is going to be the sum of area 1 and area 2. Now area 1 is a rectangle, so it's simply going to be length times breadth. So u times t plus the triangle is going to be half. Now the base is t and the height is going to be this, which is v minus u. Now we're not done yet. So S is going to equal UT plus half. Now we need to get rid of the V minus U. Now we know from the first equation of motion that V is equal to U plus AT. That means that V minus U is equal to AT. Now I can replace that. So I can have T into A times t. So S is equal to ut plus half at squared. And this is the first method that we can use to derive the second equation of motion. The second method we could use is by using the average speed identity or formula. So we know that speed is equal to distance divided by time. So the distance traveled, s, right? Let me just call that speed. So the distance traveled is equal to the average speed divided by time. Now, average speed can be calculated by saying the final speed plus the initial speed divided by 2 multiplied by time. So S is equal to, now we can replace V using the first equation of motion. Remember, V is equal to U plus AT. So we can say U plus AT plus U over 2 multiplied by T. So S is equal to 2U plus AT divided by 2 multiplied by time. Now let's simplify. You're going to get ut plus half at squared. And that's the second way of deriving the second equation of motion. And the last way is by using integration. So that's the third method. Well, we know that velocity is equal to the change in the distance or displacement divided by the change in time. Now we can rearrange this. We can say that the change in distance is equal to velocity multiplied by the change in time. Now we can take the integral of both sides. So the integral of ds is going to equal the integral of v dt. Now again, from the first equation of motion, we know that v is equal to u plus at. So let's replace that. So the integral, or the change in the distance or displacement, is equal to the integral of u plus at dt. So the change in the distance or the displacement here is simply going to be s. So s is equal to, now if we integrate this, this right hand side, we're going to get ut plus half at squared, since a is a constant. And that's a few ways that we can derive the second equation of motion. If you stuck around till the end, thanks so much for watching. Don't forget to leave a like, share this video with your friends, and subscribe for more. I'll see you in the next one. Bye bye.